Hello and welcome, and what we are looking at today are some ECUs. Now you might have noticed bank 1 and bank 2, that'll probably give you some clues as to what's going on, and this one here as well. So these are the ECUs from a 750, which is a V12, and the majority of V12 cars, even up to quite a few of the modern ones, they're still using two ECUs as one ECU. I suppose they can't fit all the chips in it to do both bank to do an entire 12 cylinders, so they separate them out into two different ones. Most V8s will normally handle one ECU, but when it gets into V12s they'll often have two, and they can be really hard to diagnose as well. A lot of diagnostics can't figure out the way to talk to each one specifically. So the issue we have is bank 1 is fine, bank 2 doesn't fire, so we're going to have a look at that one, and then this ECU is a spare ECU and we're going to be cloning bank 2 into this one, and then he's going to carry on using these two running the car. The bits that we have are important. These numbers are different, you'll see between them, but that's a BMW number and that does involve what's programmed onto them. This is the important number here, 621, 621 and 621. That's the Bosch hardware number, and that means that these are the same computer. It's the same hardware, just with different software inside. So we're going to have to copy the well, first off we'll check into these and see if we can see anything going on with them, and confirm any sort of faults, and we're going to end up cloning two into this spare one anyway, and then he's going to carry on with these two. So first thing to do, we were going to put him on diagnostics and see if we can spot anything showing up that could be of interest. There's DME 1 hooked up on a test rig. I've got this little thing built up so I can connect to various ECUs and just plug them in, power them up and get talking to them. So INPA doesn't want to play ball, so what we've done is we broke out the big guns and gone to tool 32. So if I pump the brightness up, stop the screen flicker, we've gone in, load SGBD, and this particular one is the one we're after. Usually with these things you run ident first, make sure you're getting part numbers and stuff, and the whole thing is talking and communicating, so you know you're connected, and then FS lays and is read the faults, and there we go. We have this one is just power disconnection, which is fairly normal because it's been unplugged. Can timeout EML, which is the throttle controller. Can timeout EGS, which is the gearbox. Can timeout ABS, which is the ABS. Can timeout of the second DME. Can timeout of the ECAT, which is an electronically heated catalytic converter that you'll get in some of these, and instrument cluster, and then finally EWS saying we haven't received a signal. So nothing particularly unusual there, but as with some of these M5.2 ECUs, they do have a habit of clearing all fault codes when they're disconnected from power. So sometimes that means that you can't come back and see stuff that you thought should have been there, you know, cam and crank sensor faults. If you unplug it, sometimes you'll lose all of those kind of faults. So let's have a look now at DME 2 and see what's going on with that one. Well, we're on to DME 2. One of the interesting things now is we only get the one fault for power, and we don't get anything there about CAN bus. So what I'll do now is have another bit of a look into that, and see if there's some kind of a difference. Right, back to DME 1. Same sort of thing, the same codes are there. If I clear them and then reread, we do get the same CAN bus faults. So DME1 was happy. I'm guessing There might be some slight difference in the software. Usually these were done so you could actually swap the ECUs into various different spots and they would know if they were master or a slave. Because we're getting CAN bus stuff, I will check the CAN bus and make sure that's doing something. And then yeah, we'll have a look inside too and see if we can see anything unusual. And this finally is the donor, and the donor also has the CAN bus communication, so we'll need to do a bit of digging in there and see what's going on. Is DME 2 off the CAN bus? But if it was, you'd expect it to see some code, so we'll need to have a bit of a check into that next. Right, we're on the spare DME now. There's a lot of CAN buses in there. They should all be linked together. This one technically should be high and low for the gearbox. And if we zoom in, we can see that now. If I set up a trigger just to catch some of this stuff, there we go. There is a bit of smearing on there. That's likely because there's no termination resistor on these. Normally you want to have 120 ohms between your CAN lines, and without that then you can get sort of weird ringing and so on. So we confirmed that yeah, we do have a CAN bus output from this would be the spare DME. If I just zoom out again, we can see we zoom the other way, sorry. There we go, a little bit longer, and there we have blocks of CAN messages being sent. And this is a look into bank 2. Yeah, there is a CAN bus signal there. Again, if we increase our times, we will see then big chunks of CAN bus data flying past. So there is certainly CAN communication there, even if it's not complaining about it. Back on bank 2 again, and yeah, maybe after having something on the CAN has woken it up, as now we do have the same kind of codes we had before, the power, cut down, and then the rest of our CAN bus stuff. So I wonder if the CAN was off for a while, even though it's not showing anything about it, but it looks like it's rebooted and working now. So that unfortunately means that there's nothing we can particularly spot to fix on these things, but next thing we'll do, we'll have a look inside and see if there's anything else in there showing up. So I've got him opened up now, and there's nothing particularly standing out. There's nothing I see that's burnt or anything like that. Do see a little bit of corrosion up there on that top corner. There might be more underneath that metal shield, and there is something a little bit interesting on the back too. So this is the other side of it now, and one little interesting thing I did notice is the bridge that we have between these two. I've checked though on our other donor, there is no bridge on there, and that's something that would have happened from the soldering when this was manufactured. They are showing as sort of continuous between those two anyway, so it wouldn't really cause any problems, but it's an artifact of the wave soldering. So wave soldering is something done in the manufacture of certain PCBs and components, and what you have is a molten bath of solder. It looks like the T1000 in a jacuzzi, and underneath this then there's going to be a spinning sort of a drill or something to agitate it, and that will form a standing wave in the top of the solder, in the solder bath, and then these circuit boards are passed on a conveyor belt over the top, with the bottom of it just dipping into the solder as it passes along, and the wave will reach up and touch all the bits and pieces on the bottom, and the solder will stick to where things want to go. Now, the way you can tell that this was wave soldered is by, you'll see these little grabber pads here at the end of everything. So you can tell that the direction of the soldering was this way, and the wave would be coming in along there, and the solder would be coming up, touching all of these legs and so on. And then they'll always have one of these big pads at the end, which are designed to grab any blobs of solder that want to try and stick on that very last leg, and they've got nowhere to go. So it'll bridge over onto this one, stick onto there, and then not form any sort of bridges between the last two legs. And you can see most of these chips here have these little grabber pads at the end. That's what would have happened here on this guy. Again, he would have gone through, and because there was no grabber pad, a blob of solder formed and bridged between those two. But as I said, there is a trace. All of those connections there on that side are continuous, so that's not going to be a particular issue with this. So what we are going to do now is carry on with the cloning. So when things are wave soldered, you will have all the various components will be stuck onto this board with a little dot of glue. And I think if we just zoom in, that little red dot, we can see underneath that capacitor there is one of these little dabs of glue. So that holds these things on when they're upside down as it passes then through the soldering. Because everything would have been upside down and glued, then this chip will also have little pads of glue underneath it. So that means it's going to be a little bit trickier to unsolder, as the glue is always going to be holding it down. You can heat up all the solder on the legs, but it does mean that this is not just going to come off by itself because it is glued down. So there will be a little bit of force needed to pull him up, but you have to be very careful and make sure that all of these legs are free, or at least the solder is melted, so when you do try and lift this thing up, it doesn't rip the pads off as well. This is the main flash memory chip. This is where the ECU program is going to be. The memory in these things don't change unless you have an update going on. So whatever this was programmed as 15 years ago, that should be exactly the same as what's on there now. So that's one of the chips that will get copied and cloned onto the other one. And then we have another chip on the other side as well. This is the other side with our processors and other components and so on. And the chip that we need to swap here will be this one. This is the EEPROM. The EEPROM is where changeable data is stored, so fault codes and immobilizer codes are going to be in this one. This one's designed for quick writing and changeable data. That's going to happen a lot, but it's not as good for speed as flash memory. So the flash memory will be like your main hard drive, and this one is almost just like a notepad for quick changeable stuff. If he will focus for us, there we can see a 24C04, which is a fairly common kind of EEPROM. What you're looking for EEPROMs, is this small, so if I just show finger size, small 8-pin chip. EEPROMs are usually that very same sort of size, and you can often recognize them by the numbers. So 24C04, 93C46, 953080 or something like that. I think you'd see in some of the dashboards. They're once you're used to them, you know the numbers and you know what to look out for when you are looking around for various chips. There are different ways of doing cloning. What I would normally do is take the chips off a bad ECU, chips off a good ECU, chuck them in the bin, and then just transfer this chip into that one, and the other chip as well, and that's it then, job done. In this case though, what I am going to be doing is taking this one, reading the contents and saving that and sticking him back to where he is, taking this one off, reading the contents, saving that just as a backup, deleting it, and then programming the contents of this chip into this one, and the same with the EEPROM on the other side. That would be a full clone, and then we're going to end up with two ECUs that are going to be identical. Once that's done, the new one, which I've got marked SP for spare, that's the one to start off working on. And if the problems are gone, then we know it's down to the ECU. If the problems still remain, then it wasn't down to the ECU, but there is still a spare that is working and good to go. So I have this little gadget, which is kind of a little bit like a forklift for these chips. He'll slide in underneath our legs, and then hot air then to heat up the joints and melt the solder and get this chip off. So we need to blow this around to warm him up, and then once the legs are melted, we should be able to lift this chip up. I have my air set on about 370 degrees Celsius at the moment. As you blow around, eventually you will start seeing the ever so slight changes in the solder, which can tell you that it is starting to melt, and sometimes then you will start seeing the legs starting to lift up as well. So we're going to equalize the heat a little bit. A little bit of turning torque on this forklift. It works pretty good. It is kind of like a fuse. That means that you can't push too hard into these things, as you don't want a lot of force on them. All of the legs would need to be heated up and the solder liquefied for it to lift up. You can see some of them starting to go at that edge. Starting to lift up now. You can sometimes hear ever so slight little clicks as some of the legs will take themselves off the soldering. It's starting to come up on one side, and there we go, it's coming up now, nice and gentle, and there he is. That is our chip off. And if I flip him over, that little stripe there and that little stripe there is our glue, and you can see the three little dots there in the middle, and that was how it was glued down onto the board for production. And I'm just going to clean up these pads as well, as we will be sticking the chip back down onto this once we have a readout of it. So the first thing to do, get a little bit of flux on there, and I have some solder wick here and a soldering iron, and we'll just be able to wick this solder up. So first off, just get a bit of heat back into things and warm things up, and then go on with our solder wick. Solder wick is very handy, as it's a very finely braided copper which will soak up all of the solder on there. Be careful with this kind of stuff, I would say, as well, because it can sometimes stick to some of these pads, especially if you have like a lot of the solder wick. A lot of people will just cut off a small section so it doesn't end up wicking the heat all the way along the rest into the reel. Although I managed to kind of do okay. And what we'll do is we'll just swipe him along, and we'll take up most of the solder, do another little bit along here. And I don't use any force on this thing, because if it does stick to a pad, the last thing you want to do is give it a yank and rip the pad off. So that's our pads cleaned up now. He'll be ready to stick the chip back on, but the next thing we'll need to do is read that chip and save the contents. So there's our chip. This is in a socket there, a zero insertion force socket, which you can just stick them in quickly to read them. Peeled a little bit of the label off to see what the chip is. 29F200AB AMD. And then what we do is we just take a read, and we'll see there it's active for a while. Read complete, and then always good to click verify, which will read it a second time and just make sure that everything is exactly the same, and that way then you know you've got a good read. So we have the data out of that one. We will save that and transfer that into the other chip. By the way, programmers don't normally look like this. There was a power supply that sat in there which blew up, so I have to have this whole Heath Robinson contraption now to give it 12 volts and 5 volts to power him up. And yes, I know I'm a guy who's doing electronic repairs, and I still haven't fixed the little transformer there, but that's the way life goes, really. Whilst I'm here, I'm also quickly going to get in here and get this EEPROM off. So we'll warm up the hot air. This will be a lot easier, as this side will be the stuff that was everything was sitting on here via gravity, so there's not going to be any sticky stuff underneath. When you are doing this stuff, often good to take a picture so you know which way round these things go. It's happened to me before where I've taken something off, gone to put it back on, and I realised then, you know, is it facing this way or the other way? Yeah, if you got the pictures or a video, it's fantastic. So I'll just blow a bit of warm air, or hot air rather, around this, and then eventually this thing will just lift up nice and easy. Shouldn't take too long, as this is a lot smaller. And there we go. There is our EEPROM. So similar thing with this. I'm going to read and clone the data out of this one, and then put this chip back, and this ECU will be then back original, how it was when it first turned up. So similar sort of thing. There he is in the socket for this one. That's our little EEPROM. This is one of these TL866 programmers. Handy, quick little things to have. We read the data out of him, and there it is. There's not really a hell of a lot of data in there, but some of that stuff obviously is going to be important. So copy this stuff, write it into the other chip, into the other ECU, and then that's it. So we have our contents saved now on this chip. So what we're going to do is just solder him back on. I've already given that leg, the pads there, a bit of a clean up. So I'm going to add a little bit of solder onto one of these pads. I'm going to get in with our chip, and almost like the equivalent of a spot weld, just a first little tack just to hold him down. And make sure he's square, and then we'll get another tack in on this leg over here, and then we can go back and do the rest of them. This kind of soldering is pretty easy, as you can generally just plug the stuff in and it will just stick to exactly where you want it to go. Spin him around and get the other side. And that's him on. So now we just need to give him a bit of a clean up, and that's done. So this is going to be toothbrush and alcohol, which is usually how I start the morning, and spray a little bit on there, give him a little bit of a scrub, and we'll start lifting up that the flux traces. The real other stuff, acetone, is even better and a lot easier and a lot quicker at removing fluxes, but it can affect a lot of plastics. So for example, my chip socket that you seen earlier on reading the chip, I was cleaning that with acetone, and all the plastic shattered, so I had to go and buy a new one. So certainly if you don't know what you're dealing with, stick with the alcohol. That's always a good rule in life, and that'll do it. So there we go. You do need to give it a wipe off, because what the alcohol will lift and dissolve the flux, but then you still need to remove the stuff that you've been fiddling around with. So there we go, he's done, and now onto the big chip. So there is our flash chip. I have already checked to make sure dot is going to be down in this bottom corner. He is only just placed there to start off with, so the first thing we're going to do is tack a couple of legs to hold him steady. And we'll do up here as well. Okay, so now if I just start going in, we should be able to start sticking these legs down. What I'm doing is a little bit of a push down so they touch towards the pads. At the moment there's next to no solder on there, so things aren't really going to stick at the moment, but it's enough to kind of tack things down. So now we start adding our solder back in, and this is a lot easier than you'd think, as you can pretty much just swipe around with these things and the solder will just go to exactly where you want it. Have a decent amount of flux around, and what I do is often I'll tap in, and if I can see the solder flexing its way and moving its way up the legs, then I know that we've managed to sort of wet the whole lot and we're getting a good join. I'll add a little bit more up. This is very fine solder that I'm using. The main reason for that is you control the amount of solder that you're adding in. If you've got thicker soldering wire, then it can be a bit more of a pain, as you might end up chucking too much in at the same time. So that looks to be one side done. I'll get round to our other side now. Same sort of thing. And it is really as simple as that for a lot of cases. What I'll do is add a little bit more flux, which helps things move around. That's more than enough. And as we go down, there we go. So now another clean and an inspection, and we'll just see how we got on. So a quick inspection after cleaning, everything looking good. If you want to check these things, what you can do is just give a little bit of a poke on the side of these legs, just to make sure all of them are sticking down onto the pad with the solder. I've checked all of these and everything is decent there. You don't need to go strong. It's just a very slight wiggle, and if one of these ones isn't held down, you'll just be able to see it move a little bit, and then you just want to go over it again and make sure it's all soldered down properly. So that's the data saved out of this one and the chips put back. So now we're going to move on to the spare ECU. Similar sort of thing. Unsolder both of these chips. I'm going to save a copy, erase them, and then program the data I've taken out of this ECU into the spare one, and that's it then, ready to send back. So there's the donor one now after the cloning. So that's all carried out okay. A final check then, it's always handy, is obviously go back up and check then on diagnostics, make sure everything's talking and so on. And yeah, there we go with our usual faults that we have, and as long as nothing crazy or anything like that is turning up in there, you know that the ECU is alive and well and everything's put back the way it should be. So that's it now. That's as much as we can do. We have to send that back off to the customer. They'll have to try it out and see what it's like. Unfortunately, that's one of the things you do get on some car ECUs, is you've only got one small part of the system. You haven't got the complete engine there. You can't test it on the car to see what it does. You can ask the ECU if it has any strange issues, and in this one it doesn't, but there is no real proof that that's going to run the complete engine. For example, if it wasn't able to pick up the crank sensor signal, or it wasn't able to trigger injectors or ignition coils, you wouldn't really be able to test any of that stuff right now, as it's not technically going to be doing it. It would only inject fuel and spark once it's happy with the immobilizer, and once it's getting a crank signal and all that kind of bits and pieces. So can be a bit tricky to be 100% certain of what's going on. But there we go now with the original bank 1, bank 2, which can be put to one side just as a spare for now, and our new spare, which is going to want to try out and see if that fixes the problem. So there we go. Thanks for watching, and I'll catch you on the next one. Ta-ra!